Campus Connections, a Making for Good project by Cam Dubin, Allison Lau, Ben Ballmer, Gavin Whelan, and Kiley Ross. Stress. It's not good, and unfortunately, it's become a universal symptom of college life today. In addition to the obvious emotional effects, MayoClinic.org suggests that stress can cause real physical health problems, like high blood pressure, heart disease, obesity, and even diabetes. And nowhere is that stress more prevalent than finals week. So we set out to fight finals stress by giving students a means to band together under the force of the hobnailed boot of the educational industrial complex, and hopefully show us all that when you find each other, you're never really alone. And so we created Campus Connections. Campus Connections is pretty simple. It's a computer with a box in front of it, and there's a dial on it. You turn the dial to a specific message on the computer, and then you hit the button. And it'll count up to a number showing how many people have sent that message. The interior design of Campus Connections is based on 3 key components: the flora, a potentiometer, and a button, and an output to the computer. The button sends a signal that checks in with the potentiometer. The potentiometer has values in between 0 and 1024, fourths of which align to the quadrants of the potentiometer, each one connected to a message. For example, you got this. Finally, it sends the quadrant of the potentiometer selected to a scratch interface, which updates the display based on the message selected. As in many processes, our initial idea of the prototype was vastly different than the final product. Our first setup was a basic cardboard design where users clicked on a message they wanted the other users to receive. Next, we moved to a wood model where the dial was introduced and the button was connected, and we created slots for one of the most troublesome parts of the project, the NeoPixels. We'll talk about those later. You can see some photos from the design process of stitching all of these together with the wires before we added the NeoPixels. All right, here we go, the NeoPixels. So, our original design plan involved using NeoPixels to light up in a row to show how many people had pressed the device, in rows of 1s and 10s. The NeoPixels are intended to light up when you apply current to them, like this. We built a model of the box where the current worked fine and the NeoPixels lit up as intended, but before we were about to present, the NeoPixels all stopped working. About par for the course as far as design goes. But we rallied, and over the night, we figured out a new solution involving Scratch that involved the code you saw at the demo and the beta test and the final presentation. The day of beta testing came, and the simplicity of the device was most definitely an asset on that day. People walked up to it, looked at it, turned the dial and figured out which side it bumped into and didn't move any farther into and which side it went through, and hit the button, and they had figured it out. They also got a chance to interact with the Hope Board, the physical component of our presentation. It served the same function as the device, but with post-it notes instead of the button. It has a more tactile component to it and is a little more accessible on the whole. People liked both of the components and enjoyed interacting with them, and our survey results were mostly positive. We didn't make too many changes after the beta test. We made some small edits to our poster, and finally, it was time for the day of our final presentation.